especially for people who are just kind of making the conversion from Scheme to Java and who haven't had experience with other languages. I guess I have two pieces of advice. One is to try and think more in terms of iteration than recursion. Recursion is cool, and there are definitely things that implement much more naturally recursively than they do iteratively. For example, that evaluate routine we did yesterday on OpNode, that had a really nice expression recursively, where we first recursively evaluated each daughter node and then combined them at the top. Some things you can always pretty much do anything iteratively or recursively, depending on since they have pretty much the same power if you're willing to do enough work otherwise outside. But certainly in languages like Java, for straightforward things, iteration is much more common way to implement things. And it's also the case that as the kind of looping structure or algorithm that you're implementing gets hairier, you get a lot more fine control in an iterative implementation than you do in a recursive implementation. Another reason thinking iteratively rather than recursively is good, because iteration forces you to explicitly keep track of the whole state of the kind of computation you're working on in your set of local variables. Whereas with recursion, you're basically hiding a bunch of state on the stack, and the system is taking care of that for you. Most of the time, that doesn't cause you any harm. Sometimes you are in a programming environment where you have to interrupt the computation you're working on in the middle, go do something else, and then come back and continue where you left off. Okay, and that's much harder to do if you've got this big, you've got a lot of state on the stack. You've either got to unroll your stack and store all that stuff as you unroll it, or kind of hide it someplace or continue it. So just another incentive for thinking iteratively. Plus, it's good practice. Other advice, if you're just starting out to build programs, is one, this is good advice no matter what you're doing, is to think first, program later. So it's always good to, instead of just plunging in and typing, to kind of sketch out on paper, or at least get clear in your mind exactly how you want to go about writing the thing you're going to write, what the basic pieces of state you're trying to keep are, what the basic flow of the loops or control is going to be, and then type it. Probably as you're learning, if you're just starting out, that's a little harder to do, because you need to just get a lot of experience trying things before you can just sit back and stare at the wall and think in terms of those concepts. But try and make it your goal to spend much time as thinking ahead in terms of how you're implementing things, and then go and implement them. It'll save you a few rewrites probably, though it's still useful to do rewrites. When I'm working, I'm often spending at least half my time staring out the window and listening to music, and then once I have an idea of what I need to do, it just writes itself. So at least that's what I tell my boss what I'm doing when I'm listening to music and staring out the window. So another good thing to do is to write small bits and test incrementally. I mean, write as much as you think is going to work, and then add a couple of lines to your main or testing routine. Test out that functionality, get it free of bugs, and then go on and add something to it. It's much easier to, and we'll have a whole half a lecture on testing, but it's much easier to kind of test some new stuff when everything else works than to type a whole mess of stuff, have it not work, and you have no idea where to start looking for the problem. So it's always, good to have the smallest amount of known not working code around. Okay, the technical topic for today, or the main one, is interfaces. And I want to talk about two things. Interfaces with a capital I, or what I will call interfaces with a capital I, which is a very general programming concept and philosophy and way of doing things, which you should carry through your whole career and goes far beyond Java. And then there's interfaces with a small I, which is the Java technology surrounding what are called interfaces in Java, which more or less do the same thing that the capital I interfaces do. But are also used for a number of kind of purely technical things in Java, especially in the graphic user interface stuff we will begin to see next week. The basic problem interfaces with a capital I try and address is, say you have a piece of code that does something. Let me call it module 1. And you have another piece. Let's call it mod 2. And it doesn't particularly matter what these pieces of code do, but say this one wants to call this one for a number of services. For example, say this one is going to mediate talking to the network in the World Wide Web. So it has a bunch of functionality that can open a network connection, send a URL, get back a URL, or get back some data, do all sorts of stuff, okay? And this is some program that wants to use this, all right? The question is, how does this module advertise to the rest of the world how it works, or how should it advertise to the rest of the world how it works and how to use it? And what does this module have to know about, what does the writer, the author of this module, have to know about this module to make it, to basically write this code and make it work using this module, all right? And the way you would like to do this, specify this, is in as general a way as possible. And a lot of the software technology over the past, 6 years or more, has been in trying to decouple two things like this to a greater and greater and greater extent. All right? If you're kind of working in a single directory, all right, and working by yourself or with one other team member, the problem doesn't come up so much because you write this one and you've got it in your directory, and you write this one and there's a bunch of data structures that they share and a bunch of routines that this one defines and this one calls, and everything is good, okay? Well, sort of good. You've got a lot of communication that's going on between here, these two. But what is more typically the case is that this is provided by another group of programmers, or perhaps another company, or perhaps there are several different versions provided by several different companies, which you have to be compatible across all of them. So there is a large incentive for minimizing and abstracting as much as possible what this guy has to know about this guy. In a lot of circumstances, you would like to be able to say, okay, I want to execute this guy on a different machine. So suddenly this line here goes through a network interface. But you certainly don't want to write this guy, so he has to know whether this guy is running in the same process, in a different process on the same machine, on a different machine in the local network, on a different machine on the internet, okay? So interfaces are essentially, with a capital I, the idea of abstracting this barrier, this boundary here that Module 1 needs to talk to Module 2. The basic idea of it is, again, you want to hide as much stuff as possible. So what can you hide and what do you have to expose? Well, clearly you have to expose some level of procedure call or method functionality. So you have to expose methods, all right? Now, these methods have to call things, have to have arguments and return values. So these guys have to agree also on some set of types. So you certainly have to agree on basic types, like integer, float, etc., character. I'm glossing over, even with basic types like that, I'm glossing over a lot of things, but I'm going to gloss over them all the same. And then in things like any language, you have object types, or even in a language like C that doesn't support objects, you have structured data types, collections of data packaged together in something that has a unique type name, which is analogous to our classes in Java. And here's where things get a little bit tricky, because what you would certainly like to avoid is having to have Module 1 know detailed information about the classes of Module 2. In particular, you certainly don't want to expose any implementations, all right? You don't want to, as we were talking about, hiding the implementation, the data variables in our complex class or our vector2d class with the private tags so no one could see them. You certainly want to not have this module directly try and affect, talk to, or even know about any data members in the implementation. So it seems that we sort of have that with Java classes. But Java classes, if you think about what you need to run Java classes, even that's a bit much, because in order for this guy to work, he has to have essentially the class file for all of the classes he's going to call over here. In the case of Java, that may not be too much of a nuisance. In other languages like C or C++, you do not want to have where the class information is stored in header files, okay, that tell what all the data members are, what all of the method types are, and then the implementations are in different files. You don't want to have these header files have to be shared here. I mean, sometimes they are, but that's not the ideal. So what the basic idea of interfaces is to abstract that even further so that you define your methods in terms of the arguments that they take, just like we do in a class definition. But ideally, you never have to explain when you have object types what the actual things are. You want to abstract as much as possible what even the class type is that somebody is using on this side. The idea is you just want to say, here is a handle. Often they're called handles, but the same as a reference or a pointer. Here is a reference to a thing, and the thing has some properties in that if you give it to this method, this method, this method, the right thing will happen. And if you call this method, you'll get back one of these things. All you can do with these things that you get is call methods across this boundary. So there's nothing, this guy can't do anything with these handles or things except assign them to a variable or store them. But it can't do any computation on them internally because it doesn't know anything about them. All it can do is send them back to this guy. This guy will operate on them, send them back to this guy, the results back to this guy. So you have a very high level of isolation. And the notion of what those things are is even separated from this guy. For example, in Java, if these guys are tightly coupled and this is a Java class, you would have a reference on an object. But there's no reason to have things that tightly defined in a more abstract system. There could be any sort of, this guy can send back kind of any sort of unique identifier that might be a pointer to some object in memory, or might be a string, which is the name of something which this guy keeps in a dictionary, or it could be just an index into an array of data structures that this guy keeps. The idea is to get as much as possible total isolation between this module and this module. And to the extent that you do that in especially programming large systems, your life will be good. And to the extent that you don't do that in programming large systems, your life will not be good. Now, like everything, technology and ideas, it's easy to get carried away and say, when I'm writing a 100-line program to like chop up the thing into 3 totally isolated pieces. Okay, if you have stuff that really makes a coherent local whole, you don't have to, you can have data and knowledge sharing inside inside each one of these boxes. So when you're doing a large project or getting together your programming team, or when we get together at work to do a new project, the very first thing we do is we think of these boxes, what these boxes should do, how many boxes we should have, what their basic idea is, and then specify how they talk to each other, and come up with a bunch of interface definitions in whatever language we're working in. And then these, once you have these interface definitions, these can be implemented totally independently of each other. Okay, this interface is essentially a contract between the caller and the provider that it's going to work a certain way. And so you can give these to totally different people, hire contractors, purchase them off the shelf. Once you've got them implemented, then you should be able to glue them together, and the whole thing should work. And if this one turns out to be too slow, and you have to rewrite it from scratch, then you can rewrite it from scratch, and these guys don't have to know. So, all right, enough philosophy.
Is there any advance of doing it object-oriented versus?
Well, the whole idea of interfaces is kind of doing something in an object-oriented style, but almost on a grander scale than the individual classes that we would use in Java. It's basically treating each one of these modules as an object or perhaps a collection of objects. But the same notion of abstraction you do for object-oriented, you are doing at a much higher level now with these modules, with these independently running pieces.
Yeah,
Okay.
You've been doing that in other languages before, right? The modules. These are not really object-oriented.
Could you give me an example? I lost you.
No, I guess I've heard about it. I've never done it myself, but like in other languages, you split the program up in different modules.
Right. The modules I'm thinking of are probably a larger scale, okay, different use of the word module than you would get in kind of what's called modular programming, which is those modules kind of would correspond to objects, perhaps. The things I'm talking about are really big chunks of program functionality, like your whole World Wide Web library, or, in our case, a whole speech recognition library, or a library that manages telephony function, or or interface, a whole database could be one of these modules. Basically, some wrapper on Oracle, some Oracle machine someplace. So really large pieces of data. And there are in systems a lot of different mechanisms for specifying that, depending on what sort of technology you're using. So I just wanted to point, before I got into the nuts and bolts of Java interfaces, which indeed are actually used on a much smaller scale than the ones I was talking about. I wanted to introduce this general concept and get it implanted in your mind early, since it is, I think, one of the most important things about designing large systems. All right, small interfaces, Java interfaces. Yesterday we did our OpNode example, our ExperNode example, and in order to use polymorphism, as you recall, we made this evaluate routine, and we defined it on and wrote out an implementation on our OpNode class and on our LitNode class, but on our ExperNode class, we kept it, we didn't have anything to do with it, but we needed to specify it anyway. So we wrote it out as an abstract class, okay? So an abstract method, for example. So we said public abstract double evaluate is how we declared it. Now, given that we did that, I said we had to declare the class to be an abstract class, and we couldn't instantiate that class even though it had other real methods on it, because we didn't implement it completely. All right, but we could nonetheless keep data methods or data values on it. We had instance variables, which were its left-hand daughter and its right-hand daughter. Interfaces are essentially abstract classes with no data members and all of the methods abstract. Okay. So it's basically a complete specification of something, but without any implementation whatsoever. So all it is methods, a name, and an associated set of method signatures with no implementations. For example, I will show you one that we will use today. I'll show you the Java syntax for defining one. Public, okay, and the magic keyword instead of class is interface with a small I rather. And aside from that, it just looks like classes. This interface is called comparable. I'm going to define it here, but actually this is defined in the java.lang package, so that you can use this in your programs without having to define it yourself. And a lot of the Java utility classes in java.utils use comparable. The basic notion that we're trying to get across with comparable interface is that we have some set of things. We don't know what the things are, but we know there's an order relationship between the two things. So comparable is the set of behavior associated with being able to compare two things. And the one routine in there is called compare to. And its argument is another comparable. Okay, so syntactically, that is the definition of an interface. It doesn't tell us how it's doing anything, but it does tell us what it does. It tells us that it has a single method. The method's called compareTo. It's an instance method, so it's going to be called on something that is a comparable, and it's going to take as its argument something that's comparable. And since there's no code here, there's no way to tell what it does except by looking at the documentation. And so what this does is it returns negative 1, 0, 1, or at least a negative number, 0, and a positive number when the thing you call it on, this, is less than, equal to, or greater than A in what's called the natural order of whatever set of objects you're calling it on. So this essentially is working the same way an abstract class is, all right? Say you had something like something that was, say you had a class, comparable, all right, and something that was a subclass of comparable, say ducks, and you wanted to sort your ducks, so you would basically write a sort routine or use the system sort routine, which is written in terms of comparables, and you could call kind of duck1 dot compare to of duck2, and this returns to you -1, 0, 1, depending on whether duck1 was greater than, equal to, or less than duck1 based on the natural ordering of ducks, which could be, you could implement in terms of color, in terms of size, in terms of weight, in terms of price. The idea is that you can write algorithms that only depend on the sorting property on any types of objects you like. Now, the natural question is, why don't we just use abstract classes for this? Why do we need new technology for interfaces? All right? And the basic answer is that Java only allows single inheritance. You can only have, for each parent class, you can only inherit, or from each class, you can only inherit from one parent class. Whereas often the number of kind of ways you would like to look at a given thing, okay, like your duck class would probably inherit from bird, because it is a bird, all right? But sometimes you want to look at ducks in some kind of as things that can be ordered. So the reason we have interfaces in Java is because you don't want to have to mess up your inheritance hierarchy, your kind of natural is-a relationship with all of these other different ways that you want to see the world. Okay? C++ does allow multiple inheritance. You can inherit from many different classes, and therefore doesn't need and doesn't have something analogous to Java interfaces. It just uses its notion, the equivalent notion of a purely abstract class in place of we would have the separate piece of syntax for Java. So, yes?
The comment explaining what you want the compare
Yeah.
the interface to do, does that usually go with the blank, the like stubby interface definition, or does that usually go where you actually implement?
It probably goes both. Okay? If I was really being good, and I'll talk about this later, I would put a comment up here, and I would put a comment here. And then when I implemented the thing, I would put the same comments or comments describing my implementation in the implementation. Okay? So
You don't need to keep this generic because the implementation could vary?
Well, what you want to define up here is the very genericness of it. You want to say that this, basically, this is what you'd probably put in this comment.
Okay.
Okay, and here you'd say, you know, an interface to abstract the notion of two things that can be compared.
So it's
Right, and then in your low-level implementation, you would say how you're going to do that and what ordering you're really going to do it on. For example, if you were sorting ducks, you would say whether you were sorting them by weight or by...
what greater than really means or less.
Right, exactly. So, so this is how you define one of these things. And they are you define an interface, and so they are used essentially just like classes, all right? Just like class types, interface types like comparable. So we could write now a routine to find the maximum of an array of things, all right? And just to see how that would look, public comparable array max, A max, and it takes as its input an array of comparables, which will, and we'll just implement a really simple max algorithm. Initialize my variable to null, then go through the whole array. With my standard counting loop. And basically, I want to see if my current max is greater than the current thing I'm looking at as I march down this array, and if it is, I'm going to substitute it for max. But I have to take care of the extra ugliness that max can be equal to null. So if max equals null, or the thing I'm looking at, array of I, and I'm going to call compare to. This is a comparable, so I know our current max. Let's see, open curly, close paren, open curly. If that's true, then I just do max equals array of I, and close my curly here, right? And now, when I'm done with this loop, I need to return my max, and that's it. Any bugs?
I thought that Java didn't deal with integers and booleans.
You're right. There's a bug. Alan pointed out this very bug, and I made the same mistake twice. Shame on me. What we really need to check is, as I say, the definition of this comparator is going to return -1, 0, or 1. So I really want to see if this guy is, say, greater than 0. That's what gets returned from compare2 if this guy is greater than max. So, right. And just for form's sake, I'm going to add the curly there and the curly there. All right. So, any questions? Yes?
Yeah, before you go any further, could you relate this to the two modules in the inheritance in any way in this code?
Okay. So module 1 in this case is my program Amax, or inside my program Amax, all right? And over here, the thing that I'm calling is some object that I have, okay? I don't know quite what it is, but I know that it behaves like a comparable, okay? So basically, the interface that this guy is publishing is this. It says that I'm a comparable, and you don't know anything about me, except that the fact that you can call this routine on me, and you'll get back this behavior. Actually, you need two of me's, and you can call, because you need something and something to compare it to. So you have two of these things. All you know about comparables is that you can call this routine and it'll return that.
Okay, that's good. Where do they get the other comparable then? Like, is it something internal?
Well, that brings us another issue of, we've talked about how to use comparables. We've talked about how to define an interface, but we haven't talked about any way to actually get a comparable. So that's what we'll talk about next.
Is there anything in here that makes sure we're comparing a duck to a duck?
Good question. All right, this is one of the places where the technology kind of falls down a little bit. And it has, to do with the fact that, as we talked about yesterday, this polymorphism stuff works really well on kind of the object that you're calling the method on. It can figure out what type that method is, what actual type, of the possible subclasses, and call the right method on that. Like for our evaluate, it would always call the right method, whether it was an op node or a lit node. Now, if you have to send in a second argument, that's some high-level type, it's not clever enough to, at call time, do that check for you. So basically, you won't find out until later. Can I erase this? This is in the notes.
Just really quick,
Yes.
the argument comparable.
Yes?
Is that how you'd write it in the interface definition? Is it actually any object?
Yes.
Okay.
So, I think the comparable one, if you look at the Java interfaces in java.util, some of them take as their argument, the name of the interface comparable. Some of them are more general and will take object, for example. All right, this is in the notes, so I'm going to erase this, and I didn't make any mistakes there. And rather than do what I did in the notes, which was extend the complex type, maybe I will stick with ducks. So let's define our duck class. Boy, I just had a really bad pun, which I'm going to spare you. All right, public class duck extends, we're going to inherit from bird, and implements comparable. All right, this is how, when we're defining a class, we not only tell the world that it inherits from bird, this is how we tell the world that it implements from comparable. Yes?
Would you call them instance of before you call the method to check it so that it won't break?
Yes, you need to do something like that, yes.
But then it will work always.
Right. There's a number of ways to do it. You could downcast and hope for the best, or you could call instance of. And we'll see that here. All right. If it is possible to implement multiple interfaces, okay, say we don't want, we not only have an interface comparable, but an interface cookable, and we want our poor duck to implement both of these interfaces, the syntax for that would be implements comparable, comma, cookable. Okay, so pretty straightforward. So what do we have in here? Let's have some data members on duck that aren't on bird. Let's have a price data member, so you can go to the store and buy one of these things. And then we're going to order, we've decided to order ducks. The natural ordering of ducks is going to be on their price. So we do our, constructors and accessors and our mutators. And then we finally have to get around to implementing the comparable interface. Because if we don't, this class will not compile. Javac will kindly tell us, look, you said you were going to implement comparable and you didn't. So, which means we have to implement something public. Comparable. Compare to comparable A. All right. And we're going to play a little fast and loose here and just do the following. We'll say if my price is less than, and here's where we're going to play fast and loose. I'm just going to downcast A to be a duck. Return -1. Okay. If price equals price, return 0, and the remainder is left for an exercise to the reader. Yes?
Why is this method not returning an int?
That is a very good question. It is returning an int. No, you are absolutely right. You are absolutely right. It is returning an int. And if my methods, if my things in the notes have the wrong definition of compare to, then please fix it. Excellent point. Excellent point. And of course, we're using it as an int all over the place. So you have a good future as a Java compiler ahead of you. OK, any more bugs?
Why do you downcast A as a duck?
Well, because we need to get at the price component of the thing we sent in, right?
Right.
And comparable doesn't have a price component. Comparable doesn't have anything on it. So in order to actually get at the thing the piece we're comparing to in duck, okay, we have to downcast it to a duck, and then we have access to the price component of our duck.
Is that in case A is not actually, if A was a duck, would you?
Well, even if A is a duck, this piece of code does not know it is until you put in this cast, which says, this is really, take my word for it. This is a duck. Go and get the price member.
This is not a duck.
Right. If it's not a duck and you tell it to treat it as a duck, your program's going to break, which is why you should do something like either make very, very, very sure that the only thing that can get sent into this thing is ducks, or test here to see that it is a duck. Now, the question is, what do you do if it isn't a duck? Once you've tested that it's not a duck, we'll talk a little bit about that stuff next week. So
implementing something is a lot like extending it in that you can, like the argument type for compare to, you can say the name of something that the object implements, just like you can say.
Right.
Just like you can say
exactly.
anything.
Exactly. It works, in terms of use, it works just like you've inherited from it. And the only reason it's different, as I said, was that Java only allows single inheritance up here, but it's often the case that you need to inherit multiple things. There's some cases where this mechanism isn't enough to really do what you want to do. Alan had a nice example the other day of something he was implementing that even this mechanism wouldn't cover. And in that case, you're just stuck. You have to do something non-graceful. But any other questions? We know how to define an interface. We know how, if we're given an interface, how to implement it on a class. We know how to, if we're given a class of things that implement an interface, how to use that class or use all of the things that implement that interface in an abstract way. So.
You have two different keywords in Java, right? Extend and extends. Is that correct?
No, I'm sorry. You have one, which is extends. Sorry.
So there was also the other one without it. It could be
No, I don't think so. It's always extends and implements, as in the verb. Now, just when you're thinking about how to whether to implement something via inheritance or an interface, you often, when you're starting out, have a lot of choices here, and you have to think about whether to do which. In the problem set, we have you implement essentially function properties both as a interface and as a class via inheritance. And like many things, there's no right way and no wrong way. The way to go about thinking about it is kind of think about the natural hierarchy of the things you're trying to describe in your program. Inheritance extends. It implements it represents the is a relationship. So anytime you can say X is a Y, then inheritance is a good choice. Implements represents the kind of behaves like relationship between two things. So if something behaves like something else at certain times, it makes sense to make an interface and then have everything that behaves like that implement the interface, even though they all are different things kind of in the main hierarchy. Yeah?
Since we're defining duck right here and it always implements comparable, but if the only thing we're going to do if we try to compare this with something that's not a duck is throw an error, then could we take as the type of the input to compare to duck instead of comparable, and then it would
we
take
could,
compare?
except that the definition of this interface, which gives us the definition of this
generic
routine,
definition.
right, this routine name has to match the generic definition, the routine signature, rather. So if we had to compare to duck here, that would certainly be a legitimate different routine, but it wouldn't work through the interface spec. Yeah?
I'm wondering, could you explain the difference between the way you did the comparable there and the way you did it on the notes? It's completely different in the notes.
The array thing?
Yeah. I don't recognize that your if only has two things after it, which I've never seen before. And most of that code I can't even decipher.
Right. I think the answer is that, you must have printed out a really old version of the notes. Okay. Here's what is happening here, and it has nothing to do with Java or anything else. It has to do with HTML, and if you do a structure like this for any X in HTML, it's going to delete everything between that open bracket and some remaining closed angle bracket. So the fix, and this only works for HTML, not XML, is to put a space there. And then it actually treats that less than sign. So that's a typo in the notes. If you print out a more recent copy, It will be fixed. It does not have the duck example. It has a complex example. But yes, I was alarmed because I usually look at the text version, and the text version looks fine. And then you look at the web version, and this is a pain in XML because you have to go through and, write this instead of less than all over the place. Yes?
Going back to the original definition of interface as essentially an abstract class, what I didn't get yesterday about abstract methods is why you would need to declare, why you couldn't simply have a concrete method in every subclass. Why you would, if you had a concrete method which would,
Right.
which had the same name in every subclass, why you would need an abstract method.
Ah,
in an abstract class.
because if you write a algorithm in terms of the abstract class, the compiler or the runtime system, when it's running it, has to know that it effectively wants to be guaranteed that there is going to be a routine like that on all of the subclasses. In a sense, it's just that it doesn't trust you to do it on all of the...
It's hand-holding for the
It's hand-holding, it's error checking, yes. I mean, conceivably, you could make it work that at runtime, you just went and tried to look for this class. But Java and most languages of this type try and do as much checking as possible at compile time. And a lot of the features of Java are hand-holding. So, yes?
Just some simple technical things to confirm that I understand what's going on. An interface only has only has methods that are undefined, right?
Right.
Okay, and then every class that implements an interface has to define all those,
Yes.
right? It can't leave any of them
Right.
undefined.
Right.
And then what if you wanted to implement two different
Interfaces? Comma.
and that?
So, the second point you raised is an interesting one, that if you implement the comparable or some other interface, you have to implement all of the methods of this interface. This turns out to be a real pain. Once we get into the Windows systems in Java, the graphic user interface system, or any other really Java-oriented library, everything is defined in terms of interfaces, and there's interfaces galore. And so, first of all, when everything's defined in terms of interfaces, you've got to be able to have a class that actually implements it to do anything. So all of these packages will also define these wrapper classes, which are often called comparable wrapper, which do nothing but give you a null interface to all of the methods, so then you can implement only the ones that you're interested in. And we'll see that again in the Windows system. The first example in the Windows system you would like to do is to put up a window and then click on the little X button and have the window go away and the process die. Okay? And in order to do that completely in Java, you have to implement some interface which has 6 methods on it, most of which you don't care about at all. You just want to implement that one that says, when you get a click in that upper right-hand corner, die. So you've got these other 5 to worry about, and rather than all the time have to implement these other 5, you have this kind of wrapper thing which does that. So it just multiplies the number of types amazingly.
And then you extend that wrapper.
Yes, and then you extend that wrapper to overwrite the single one you want, and then the interface is happy, the wrapper's happy, you're happy. But it's a long way.
Could you explain that thing with wrapper? I didn't get it.
Oh, wrappers are they're nothing in the language itself, but just a kind of convention that's evolved. That, as I say, interfaces have no class associated with them, right? So you can never call new on a interface, right? You can only call new on a fully instantiated class. You can't call it on an abstract class or an interface. And in order to have anything to move around, you've got to call new on something, okay? So often when people give you a module that has an interface on it, a library that has defined in terms of an interface, they'll give you a wrapper class too, and it usually would be called like comparable wrapper, and this would be a class, and it implements comparable. And then it just has this compare to that doesn't do anything. It would actually have the right types, which I neglected, but it doesn't do anything. So the only thing this is good for, actually it might even be abstract. The only thing that this is, actually, I take it back, it can't be abstract or that just kills the whole purpose of it. The only thing this is good for is that you can allocate one. You can call new on one. It doesn't do anything, but, and it's kind of silly if you only have one routine on the interface. But you have an interface that has like 10 routines, all right, and you only want to implement 2 of them. You really only need 2 of them. It's nice to have this thing so you don't have to constantly be typing all these empty definitions all the time.
So where do you put that class inside your implementation?
No, these would be typically, it would just be another class definition. It doesn't go inside anywhere, but and you can do this yourself if you want. This is just a convenience thing that somebody might do. Is to give you an actual class that implements comparable but doesn't do anything. So you can always at least get one. It sounds stupid now, but it will turn out next week to be like really, really a good idea.
The problem is, like in our example, if you're implementing it in a subclass of something, it couldn't also be the subclass of that wrapper. Right? So you wouldn't.
Right. If you're doing some inheritance, right. If you're doing something fancy like this, right, the wrapper stuff isn't useful. The wrapper stuff really comes in when you're doing things in the window system, when the window system says, okay, in order to do something when this button gets clicked, you have to give me an object that you created that obeys the, say, button click listener interface. All right? And this button click interface that the window system defines has like 10 routines in it. You have to go then implement all those routines in a class, give that class back to the window system, and so it's really for this callback functionality that it really turns out to be useful. So don't worry about it till next week when it will become part of your DNA. Last topic is JavaDoc. I'm going to erase this. JavaDoc is not really part of Java, but it is exceptionally cool, and it is becoming pretty much industry standard on the way to document things. It actually only works on Java, but there is a similar thing called Doc++, which we've been using the past year, which works on C++ and C and Perl and stuff like that. So the basic idea, this is a technology for documentation. The least appreciated and least fun part of programming, but also one of the most important. And what JavaDoc allows you to do or tries to do is, A, it shifts a lot of the burden for documentation onto the programmer, where it belongs. User-level documentation, we'll talk at a high level more about this later, but kind of your manuals that you publish get written by your tech writers. But documentation, API documentation on classes that you've written, on interfaces that you've written, that pretty much how to use them has to get written by the programmer. And if you write it kind of in a separate test file, you have the text file, the problem of keeping that text file in sync with the code you've written. You can go and change the code, add routines, subtract routines, and you're just always too busy or too tired or have something better to do than to go update the documentation. So plus, if you do it by hand, you've got the problem of formatting the documentation and all this. So JavaDoc is this cool tool to take comments out of your code and produce cool documentation. In particular, by default, it produces this very nifty tree this essentially website that describes all your classes, all your methods, all your interfaces, your inheritance hierarchy, links them all up beautifully, and lets you click between them. If you go online to the Java system documentation, which is one of those links in that how-to I put on handout 1, I find that the most useful thing in the world. That is a JavaDoc rendering of pretty much the entire Java runtime class system. So all of the classes in, say, the math object, or in the I/O package, or in the network package are all there. You can click on the package and go through the classes and interfaces, find all the methods, what they expect. It's very nice. And all you have to do to get the power of this stuff at your fingertips is to add some special comments to your code. And the special comments all look like this. They all start with /. The normal Java comment syntax is /*. Anything that starts with /** is going to be interpreted by JavaDoc. And then, of course, you have to close your comment, or the rest of your program will disappear. So then, and just for form's sake, most people will run a line of stars down the front of their comment. I would always do that.
Does JavaDoc automatically remove those?
Yes, yes. JavaDoc will pretty up things. So then you basically write a comment on the first line that describes the thing you're commenting on and what it does. Okay, blah, 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 blah. And the form of this comment, JavaDoc will let you embed HTML in that comment, and it will incorporate the HTML and display it nicely. So this is where you put, in this first comment, your main description. And I believe it takes it apart in that the first sentence is separated in kind of the brief sketch of the methods, and then the whole comment is put in the detailed version. It gives you both a brief and detailed version for each method. It also has a whole series of special things that begin with @. And you'll have to go to the JavaDoc documentation, which is also, there's a pointer to in that handout I gave you, to get the complete list. The most interesting ones are things like param, which, if you want to describe to the user what you expect the meaning of a particular argument to a particular method is, this is what you use. You use parameter, and then the name of the argument. Let's see. Now, if you're like me and have all of your variables named A, this is not so satisfying, but say we have my duck, and then following that, you have the comment. Okay, so basically what it will do when it sees one of these is make a special comment in your array description and document this argument and associate this comment with it. And it'll just make it look good. Other interesting ones are return. Here you put in a comment and it will document what the return value means. Okay, so anything you want to say about your return value, for example, in our comparable interface, we could put that returns blah, blah, blah here. There's other things that are more documentation or description-like. You can specify an author so somebody using it knows who to complain to. There's another one called C, where you can put the name of another method or class. And so if you want to kind of, in your comments or something, refer somebody to the comments on another class, you can specify that in this @C comment, and JavaDoc will go and put in a little line, and it'll put a web link here, and it'll all go. So now where to put these things? You probably need to, what you would like to do is put them in 3 places. Let me clean this up a little and just move this down to make some space. You want to put right above your method, or your class rather, class or interface, depending on what it is. Here, right above this public class, you put your comment describing the class. JavaDoc will doc for you all public data members, so public data doc. Okay, private things, anything private, even if you have a comment there, it's not going to document because it's private and the person using it shouldn't know about it. So JavaDoc will only document public things, explicitly public things, which is in one way a pain because in order to use it, you must have the word public in front of all of your classes. Even though kind of classes default to public, you must have that public keyword there. Otherwise, JavaDoc will run nicely over your software and say, could not find any public classes to document.
So does that mean that you can't define multiple classes in the same file?
You can only have one public class.
Per file, right. So essentially, yes. Oh, and finally, in front of each method, method doc. And that's the method doc is where it makes sense to have the param comment and the return keyword. The author probably should belong up here. There's other ones for like copyright and blah, blah, blah. But if you just use these, we'll be happy. But I highly recommend you use this. As a matter of fact, in problem set 1, we insist you use it on the poly class just to try it out. And as you work with bigger and bigger systems, it is always a pleasure to run across libraries or something that you're trying to use that people have done this with. It is an excellent technique, and as I say, I think it's becoming more of the standard. There's certainly for Java. For other code, there's Doc++. GNU uses a slightly different syntax that essentially does the same thing. Doc++ pretty much uses this syntax. JavaDoc, I believe, will also take, instead of producing HTML, you can give it the right arguments to produce a LaTeX document so you can print it out, or a PostScript thing, or something that's printable, which is also very nice. So since we asked you to do this in the problem set, I wanted to say a few words about it. Plus, it is totally excellent. And also, I highly recommend, when you're doing work for the rest of the course, you get to know and love that the JavaDoc stuff on the Java site that there's the pointer to. All of the classes that you are going to have to use are there and nicely documented, and it's essential.
So how do you run this?
Oh, good point. Good point. Yes, the command is JavaDoc, and I highly recommend, make up some subdirectory in your directory. I usually call it doc, but whatever you want to call it, and use this -d argument. If you don't use the -d argument, it will piddle in the current directory, and this thing dumps a lot of files. So it will it'll make your current directory a big mess. So I highly recommend the -d option. And then Java dot dot dot. So just the list of Java files, star.java may be in your directory. There might be a way to do this incrementally. I have not found a good way to, say you've got a whole mess of stuff that you want to update a little bit at a time, your documentation as you add new classes and the like. I don't know if there's a way to kind of just add a new class to an existing JavaDoc pile. This will pretty much reproduce the whole structure. So if anybody does know how to do that, let me know. Any questions on JavaDoc or how to run it? Or
So you need to put all the .java files that are in your package and do it all at once.
I believe so, yes. I'm not a huge JavaDoc hacker, so there might be a way to do it that is not that way. And certainly you can expand, paths with subdirectories and stuff in there as well. But
The private methods are also ignored.
yes, anything private will be ignored. All right, I think that's it.